All right, hi everyone. Welcome to the top efficiency features in 3DCS users conference presentation for our 2021 Global Technology and User Conference. I will be your presenter. My name is Spencer Strouse. Our agenda for the day, I've 17 total kind of hidden gems, tips and tricks within 3DCS. These range from super simple things that you're probably already doing if you're an experienced user, to new tools that we just added for 7710, our most recent release. So it's going to be, and I think even a few things that might not even be there yet and might not be there until 7.7800. So it's going to be a few very simple things as well as some more, not necessarily complex things, but maybe some stuff you didn't know about or didn't know about yet that would really help. I've tried to divide these into three basic categories, which are, kind of things to set up before you start modeling, things to remember while you're modeling, then also a few post-modeling / validation tips that we have for you guys when you're looking at your results. I also bookend that with an introduction of the model before we get started, and then also a little summary at the end about what we learned, what we covered. So, as mentioned, my name is Spencer Strouse. I am a dimensional engineer working with 3DCS at DCS every day. I've been with DCS for about 5 years now. Prior to that, I spent 5 years working at Caterpillar as a dimensional variation analyst. My role at DCS is an application engineer. So, if you guys ever call for tech support, I might be the one to answer the question. If you've been trained, I maybe was the one who trained you, do some consulting work as well. So a few different roles there. So first, I'm going to introduce the model. The model is going to be our smartphone model is what I call it. And so I'm going to hop into SolidWorks here to quickly introduce the model. So this is going to be our model. It's got a few different parts in here, one subassembly. If I unexplode my model, you'll see what it looks like when it's in its nominally built position. It just looks like a standard smartphone that you maybe have in your pocket right now. If I explode it back out, we can see all the internals again. Also, just as a note at the start here, we are going to be using 3DCS SolidWorks, so I'll click Update Model here so we can get a look at what that looks like. This is 3DCS integrated into SolidWorks, so you can see that we just have an extra ribbon in our SolidWorks tree here that has all of our SolidWorks workbench here that has all of our 3DCS icons laid across the top. This is very similar to how we handle it in NX or Creo if you're one of those users. And then we also have our 3DCS model navigator here, which again is very similar, very familiar to any NX or Creo user. Everything I show you here is going to be available on all of our platforms. So it might be in a different location, specifically in CATIA, because we have our workbench set up differently. There are maybe a few differences that I'll point out on how we implement things, but all of the functionality will be available across all of our CAD platform packages. But I'll just be using SolidWorks for the demonstration today. So with that being said, let's get started. Before modeling, and again, I tried to divide these into three categories, but they don't exactly fit perfectly into their categories. But these are generally things you could do before modeling. And the first one here is going to be our tree structure. So at DCS, we recommend that you use subassemblies to represent your assembly sequence. And then also, I'm going to recommend that you group your fasteners together to easily hide them, but keep them available to you for reference. So on the left here, we can see a bad tree. It just has everything in the same level, so it might be difficult for you to track things down, and also it might be more difficult, more nuanced for you to correctly or accurately display your assembly sequence. And on the right here, I actually have what I would call a good tree. So I have my parts. I have all of my parts from my PC board subassembly in a PC board subassembly right here. And then I also have all of my fasteners grouped in a single group, so they're easily hidden from my model, but also still available to me should I need to reference them for any locator or any circle interference measure that I want to make down the line. So hopping into SolidWorks here, My first model I'm going to show is called Bad Tree. And you can see that's what we're seeing on the left here is just a bad tree all the way down. Everything is in the same assembly level. If I hop over to my next model, which is called my before modeling model, I have a better tree, you could say. Now I have my fasteners all grouped in one subassembly, as well as my PC board subassembly all grouped together. You'll notice that 3DCS, again, this is common across all of our platforms. We are just stealing or mimicking mirroring perhaps, the tree structure that's available within the CAD platform. So the CAD platform here is perfectly matching my 3DCS tree. So in order to update your 3DCS tree, we'd actually have to go in and change the tree structure of the CAD platform. That might not be available to you because maybe of some PLM reasons you can't actually do that. That's fine. You can still model with whatever tree structure you're given. It just makes it easier if your tree structure actually mimics your assembly process. And if you do have the freedom to restructure it, I really, really like this fasteners group idea because these 4 fasteners here I have in my model. Maybe I'm going to want them later on so that I know what size bolt I'm trying to put through that hole when I make a circle interference measure, but they aren't doing any real locating work for me. So it's going to be real easy for me to just in SolidWorks, just hide all of those at once. And then now they're out of my face. But now later on, when I need one of those, I don't have to go on hunt through the first subassembly, find all the ones to unhide, hunt through the second one. It could take a very long time to find the exact bolt that you wanted to unhide to figure out the size of it. Whereas if you just have all 120 or whatever fasteners that you have in that assembly file in one subassembly, it's very easy to just hide and unhide all of them at once and get that information that you might need for your analysis. So that is tip number 1. That is setting up your tree correctly. And again, this might not really be a factor for you because you might be starting from an already built assembly file. But if you do have that freedom or you do need to set something up, this is kind of my recommendation for it. All right, step number 2 is exploded views. Separating the parts, while not entirely necessary, it does help improve visualization and really prevents mistakes, especially for new users. So I'm going to hop over to my model again here. In my SolidWorks model, I do have an exploded view. So that's just going to be located right over here in SolidWorks. It's going to be different location depending on the CAD platform you're using, but we're just leveraging whatever tool is used within that CAD platform to separate the parts out. In SolidWorks and Creo, it's called exploded views. In CATIA, it's called scenes. And in NX, it's called arrangements. So we're just going to leverage on, kind of piggyback whatever functionality they have there. So, and again, technically not mandatory for a 3DCS analysis to separate your parts. It just might make everything much easier for a couple different reasons. The first reason is when you're actually creating your moves, which we're going to be doing later on in this presentation. It's just going to be easier to select the actual faces that you need. For example, if I wanted to select this face on my green part, my PCB right there, it's pretty easy when everything's exploded, but if it's unexploded, then I'm going to have to go to this part here. I'm going to have to hide it. Then now I can select it, but wait, I wanted to select the corresponding face on the other part, so now I'm going to have to go in here. I'm going to have to unhide it. Oh, now I can't see that face, so I'll have to hide this one now. And it just kind of drags on a little bit, in my opinion. Whereas creating an exploded view just really, speeds up that process of selecting those faces, creating those points. Go ahead and unhide that one I just hid. So I'm going to explode my model back out here, and you can see it'd be much easier. The other thing that it does is it can help to prevent mistakes, and I have an example model for that one as well. So I'm going to hop over to this one that's called Bad Exploded View. So you can see this model is currently exploded. I'm going to actually unexplode it real quick. So I'm going to unexplode it, update my model to tell 3DCS those parts are now unexploded. And okay, so now If I click separate, parts are going to stay in their nominal positions. If I click nominal build, parts are going to stay in their nominal positions. There's no graphical validation that my moves are working as expected. There's just graphical validation that my moves are not, throwing a part way off to a place where it shouldn't be. So what can happen is if I choose nominal build and then I choose deviate here, I can see, I speed it up a little bit. I can see my parts moving around. I could hide some parts and see all the internal pieces, components moving around as well. But I'm not really getting any validation that everything, I'm not getting as much validation as I could from my moves that everything's working as it should. It looks like it's working as it should. Once I get some results, maybe a contributor could be missing, but maybe I'd miss that. Well, there actually is an error in this model that might surprise you to learn. And if I apply my exploded view again, I'm going to update my model to tell 3DCS that I did that. Then now when I select nominal build, we'll see that my camera, as well as my charging port up here, stayed floating above my assembly. It's like, wait, why did that happen? Well, in my model, while I do have moves for everything, it looks like I'm missing a part of it. Maybe a move part's missing. So I'm going to separate my model back out. And then this time I'm going to animate through those steps one at a time. Because again, this is one of the big advantages of exploded view, is that the animate function is actually going to step us through how our model is built. So first step is going to be that charging port moves to my green board. Next step is going to be that my camera goes into position there. Next step is going to be my battery goes into position inside the housing. And then my next step looks like it's going to be my volume buttons are going in. So if you look at these ones, they're going to be going in next. Lock button goes into place. But then my next one says is PC board to housing right here. And if I click next, we're going to see that my PC board moved in. However, the camera and the charging port that were initially moved to the PC board did not go with it. And so you might be wondering, like, what the heck happened there? Well, I'm going to go into my PC board to housing move right here, and we're going to see that instead of having the PC board subassembly as my move part, I instead have the PC board itself as a part as the move part. So I'll have to go through my tree here and just find my PC board subassembly and then select that instead as my move part. And typically, if your tree structure is created correctly, 3DCS is automatically going to pick up the fact that you want the entire PC board subassembly to move together. But maybe something happened, maybe you changed tree structure down the way, something happened, it only got that one part. Well, it's a really easy fix, to fix that when that accidentally happens, but it could be a little bit more challenging to catch that if you don't have an exploded view. So again, very easy to catch with exploded views, so that's why I recommend you use them. And then now that that's there, we're going to nominal build, and we're going to see everything looks good now. There's no confirmation that something's wrong. All right, so that is bullet point number 2 is exploded views. On to number 3. 3s are GD&T defaults, and this is really one that you should set before you start creating all that GD&T within 3DCS. So this model is actually very small parts with very tight tolerances. So I'm going to go into my preferences here. I'm going to choose distribution defaults. And I'm going to reset this page to its default settings so that we can see what they would be. And primarily focusing on this surface location default, I can see that I have a default range of 1 millimeter. What that means is that every time I create a profile tolerance, it's going to default to having a range of 1 millimeter. Well, for this specific model, 1 millimeter is actually a massive tolerance. I'm holding all these parts really tightly. They're really important components for my, my assembly here. So my default, I'm actually going to make 0.1 because that's a much more common tolerance that shows up in my model. So this might not save you a ton of time, but it does save you a little bit of time at least when you're creating these tolerances over and over again. If you're constantly changing it from 1 to 0.1 over and over, it could be a useful tip there. So I'll click apply. Likewise, you could do the same thing for a position tolerance. You could change that one. You could change your size tolerance default. My size tolerance default defaults to 0.1, so that's a range of plus or minus 0.05, sorry. And then the other thing that you can do is we have a lot of customers say, you know, your software is defaulting to a sigma number of 3, which is a CPK of 1. Our process holds a CPK of 1.33. We require that. So is there some way we can change that within the model? Well, if you change this number right here from 3 to 4, which just equates to a CPK of 1.33, then that means that every tolerance that is created from that moment onward will have a CPK of 1.33. Also in MTM defaults, the only one I'm really going to cover is our spec limits. If you're finding yourself making hundreds of point distance measures and the spec limit is always going to be plus or minus 1.5 or plus or minus 0.25, you can by default change that here so that every measure you create could have a range of plus or minus 0.25 instead of plus or minus 0.1. So now, just to experiment with that a little bit, let's go ahead and choose GD&T. I'm going to put some GD&T, let's say, within my housing. Looks like I already have a bunch of GD&T in there. That's because I'm still on my bad exploded view one. I'm going to hop to actually my previous model called before modeling. So I just have an empty model over here. And then now I'm going to go back into my preferences because that's model specific. So let's make sure. It looks like maybe it's not model specific. Maybe I misspoke there. Yeah, it looks like it did. It does remember the changes that I made, so that's nice. And then now let's go ahead and do some experiments. Let's make sure that that worked the way I intended it to do. So I'm going to go ahead and create a service profile tolerance. All right, defaults to 0.1 for the range. And let's head over here, and we have a sigma number of 4. So that's nice. And let's go ahead and add a feature to it. Let's say I want a service profile tolerance on this face right here, 0.1. And click OK. Also, we changed the for the measures. We also changed that. So I'm going to say measures. I want a point distance measure, and yep, and there's the defaults are now plus or minus 0.25 instead of plus or minus 1. I'm not going to worry about actually creating a measure right now. Let's go ahead and just exit out of that. All right, so that was number 3, was GD&T defaults, and as well as measure defaults, I suppose I also showed you guys there. Number 4 is going to be Alias Display. I think Alias Display is a very, very powerful tool, but sometimes people don't know about it, so I like to point that out right now. So I'm going to head back into my GD&T measure, or sorry, my before modeling model right here. And I'm going to head into my preferences, and I'm going to head over to my Alias Display tab. It looks like I already have some Alias Displays set up, so I'm going to go ahead and say reset settings on this page so that it resets them to their defaults. And then now if I go into my housing, I have a GD&T here. One common thing that I really like to do with the Alias Display is I really like to go ahead and choose GD&T customize. And then now I can customize some filter that goes over all of my GD&T. And one that I really enjoy doing is like, I want my GD&T name, and that should be followed by, inside of 2 parentheses, my GD&T range. And then I can apply here, and we'll see that now it says profile range of 0.100. You could also, add anything you wanted to this. You could also say, I also would like to know the GD&T type, perhaps. Click OK there, click Apply, and it'll say service profile after it. A little bit redundant because I already named it profile, and it also shows the service profile icon right there. But, maybe your naming convention's a bit different, or you aren't familiar with the icons, so you'd like to also see that show up too. And the other thing about Alias Display that is super powerful is this part customize option right here. This is, I believe, new, maybe in 7710, maybe 7700 we got this in there for. But previously, we were kind of beholden to whatever the name was within the CAD software. So the example that I have in my model for this are these two volume buttons. I have one volume button that turns the volume up for all of us who are familiar with how smartphones work. And then I have another volume button that's going to go right here that would turn my volume down. Well, those both have the same name because they're the exact same part. And so what that means is that in my tree, I just have one that's called volume button 1 and one that's called volume button 2. And I don't know which one's which unless I highlight them and see what highlights. So I'm like, okay, volume button 1, that's the up one, volume button 2, that's the down one. So I could remember that, I could continue to forget it, or I could address that right now by customizing the names. And so I can go into either of these edit part dialogues by double clicking on either of them. So I'm going to double click on my volume up button one. And I already accidentally renamed this, but by default, you're going to see it just say CAD part name and DCS part name are going to be exactly the same. Well, I just want to change this one to be volume button up. And then I'm going to go to the other one and say, I want that one to be volume button down. And like I said, I already renamed these accidentally, so they already show up. But you'll notice that nothing changed in my tree yet, though. So it's like, what the heck? What did I actually do here? I feel like I didn't change anything. Well, let's head back into Alias Display. And now I have to create a custom filter for this because by default, it is just beholden to that tree name that I have over here. So let's go ahead and just change this so that instead of it being the CAD name, we want to use the 3DCS name, the one that I just created. So I could either type in that D there, or I could just delete this and then just click on this and it'll add it in for me. A few different ways you could do that. And then I'll click OK. And then I'll click OK again. And then now we'll see my tree updated to reflect that change. And then also you could customize any of these names. So I could say this is housing from April 2021, just to kind of bookmark that. And then that'll show up right there as well. So it's a pretty fun, neat new thing, especially when you have this common part situation that I brought up and you just want to have a different part name so you can remember what it is. The other real benefit that I found for that within my models is that, and I don't have a good example of that here, it looks like, but sometimes you have a CAD part name that is like just a part number and just means absolutely nothing to you. It's just like 45-68217. And I'm like, well, that's important to me because I do want to know what the part number is. So when I'm looking up drawing, I can find it. But for the sake of my modeling, I wish it would just be called the ignition switch or whatever it might be. So I wish it was just called that instead. So you can easily change that within this DCS part name so it's easier for you to model. All right, moving along. Number 5 is mesh color, and this is our last one in the before modeling phase of this. Whoops. So I'm going to hop back into my model one last time here. And I'm going to mostly have my mesh display turned off for this just because there's a lot going on in this model. It gets a little bit busy on the screen. But for right now, I am going to turn my mesh display on, and we're going to look at the mesh that I have on this face right here. It's a little bit difficult for me to see the meshing on that face. And if I use this fast point creation, just create a bunch of points on this part, I'm going to end up with a lot of mesh. Well, once again, it's not the easiest for me to see that mesh surface. Maybe for you it is, especially on this face, I'm finding it very challenging. Well, one trick you can use is heading back into the edit parts dialog. By default, 3DCS is picking up the color of the CAD geometry and it's assigning that color to the mesh, which is nice because it helps identify which is which in the tree. However, sometimes difficult to see. So you can improve visualization if this becomes a problem for you by clicking on this analysis mesh color button. And you could change this to be something spectacular different, like this pink salmon color here. And then now it's very easy to see it. However, now I don't really have a relationship between the color here and the color I'm seeing on the CAD, so maybe that's confusing to you too. So sometimes what I like to do is I just like to choose not exactly the same color, but a color that's close to it, so that I can see the mesh, but also it has some relationship to the CAD, and I can kind of I get that visual cue to what's what. So I'm going to choose this slightly darker brown color here, or gray color, and then now it's a bit easier for me to see, but this gray color here still kind of mentally equates to the same thing. All right, so that's mesh color. And with that, we've concluded our first section, which was our before modeling section. Now I'm going to jump ahead in the modeling process to the during modeling phase. All right, so first thing we're going to do here, number 6 on the overall tally, is the right-click menu. Some people are a big fan of this and almost exclusively use it to add things to it. Other people, may not even understand it exists. So for this one, I'm going to, again, we're hopping forward in the modeling process. I'm going to hop forward in my model to my next model right here. And you'll see that I now have, my tree is now populated with a number of 3DCS features because I'm, probably about 30% of the way through the overall modeling process for this. I just have a few features in there. If I click nominal build, we're going to see a few moves get applied. Not all the moves get applied. We're partway through the modeling process. So like I said, the right-click menu, you can right-click on any part, and it's going to pop up with, at the top here, this nice right-click menu options. You have add move, add tolerance, add measure, add GD&T, or add group, which we're going to get to later. But this is just a simpler way for you to add a GD&T or a tolerance, measure, move without having to select the button up here, select your part, maybe in the tree, maybe in the graphics window, and then that opens up my GD&T window here. I have to hunt down which one I want, parallelism perhaps, then click add. That's just a lot of steps perhaps. So maybe instead of that, you just want to right click on your housing and say, hey, I want to add a parallelism. So just fewer steps, a different workflow. Maybe you're a fan of it, maybe you're not. Now you know about it. We're going to be using it a few different times throughout this presentation. I don't have a specific thing in mind, but I assume that I'm going to be using it a bit because I'm pretty comfortable with it. All right, number 7. This is a complex one. I'm going to try to keep it as simple as possible, but it's the feature move. And one way to really improve your efficiency in the modeling process, to really speed up your modeling time in terms of model creation, not necessarily analysis time, but model creation time, is to for simple locating schemes, you can really use the feature move effectively. And my recommendation that we're just going to stick to for this example is only use it when you have one feature in each of the fields, and then it'll work as expected. So especially if they're, again, simple locating features. I'm not talking about like two curved surfaces to each other. Sometimes the feature move doesn't do too well with that. But if you have like planar and axial features, the locating is pretty simple. You can really save some time by not having to create points and everything by using the feature move. So for my model, the example that I have for the feature move, and again, I'm just going to turn my mesh off. It's a little bit busy. For my model, the example that I have is I'm going to move my PC board to my housing. The PC board locates by this bottom face, touching off on the top of these kind of ribbing features here. And then it also has a pin up here, as well as a pin down here. And then I have a hole up here that corresponds to the top pin as a 4-way. And then I have a slot down here that corresponds to the pin as a 2-way. So I'm going to get my model navigator back. I accidentally closed that when I was panning around. And then I'm going to head down to that area, and I'm just going to right click here and say I want to add a feature move. So I'm going to say I want to move the PCB to the housing for the name. And then again, I'm going to stick to just having one in each of these fields because that guarantees that this is going to work. And I'll show you an example in a second of when that wouldn't work if I have more than one. But first, let's just go ahead and select my primary, which is going to be my plane. My secondary is going to be my 4-way. My tertiary will just be my slot over here. I think I've already got this slot declared. Yep. And this is a new feature we have. in all platforms, you're going to see a line between the two slots with a little diamond in the middle of it. And that means that there's a slot there, and you can graphically select that to select the slot. Previously, I think we were only able to select slots in NX, so for NX users, this might not be new to you, but now we're getting there with all of our platforms, which is nice. So I'll select that, and then that'll populate with my slot. And I already created that slot before this, so that's why the slot was already there. All right, and then now down to our, and again, my mesh display is turned on, which slows down my panning and rotating a little bit, so I'm going to turn that back off. And then on to my housing. So for that primary, it's going to be that face right there. For my secondary, it's going to be this pin right here. And for my tertiary, my pin over here. All right, and so now I have that move completed. If I click nominal build, puts that part into position. Things look good. If I click deviate, we can probably see some floating happening between the hole and the pin up here. Things are looking pretty accurate to me. Go ahead and close that off, set from model back out. And so you can imagine that that's much faster than the alternative of creating our 3 points for our plane, copying those over, projecting those points, and then also creating a step plane move at the end of all that. So it's fewer clicks. It prevents you from having to create all those points and copy all those points and project all those points. So it's a bit faster. However, I only recommend it with these simple locating schemes where it is just this a pretty simple one feature in each of those is gonna get the job done. Like I said, I'm going to show you a situation where it would not work, and this is going to be a familiar model for everyone, the headlamp assembly that everyone's been trained in who uses variation analyst. So this lamp right here, this turn lamp, is locating to my bracket, and the problem, and why I recommend that we do not use the feature move for this, is because it has these 3 posts that are all locating to these 2 faces on my bracket. And so in this model, I'm going to update it real quick. I currently just have the correct move, which is the step plane move. And if I deviate, I just have a very large tolerance on this face right here. If I nominal build with that step plane move and then deviate, we're going to see that my turn lamp is kind of, it's bobbing around, it's moving around with this face. It's basically staying stationary right here because I don't have a profile tolerance on this face. I do have a large profile tolerance on this face to make it move up and down. Now, if instead of that, I didn't want to create those points, I didn't want to create a step plane move, I said, you know what's easy? Making a feature move. So I added a feature move to my model. I said feature move example. And then for my primary, instead of simply selecting one of these faces, I'm like, hey, wait, it actually encompasses all 3 of these faces. So I'll go ahead and select all 3 of them. For my primary targets, those 3 faces are going to these 2 faces. So I'll just go ahead and select those 2 for my primary targets. For my secondary object, I'll select my pin here. And again, for my 4-way and my 2-way, I actually only have 1 pin for each of them. So that's actually going to work fine. The problem comes from our primary that we're going to see in a second. So I'm just going to select these corresponding features. And I think I got those all right. CAD-Serv 4, difficult to see, but I think I have all of those correct. But let's just click nominal build and see. All right, so I got the pins correct, but look at what's happening to my model right now. So you'll notice that it seems like it's actually pushing through to the other side, whereas for the feature move, I told it to line it up to those faces. It doesn't seem to have done that at all. And so what the feature move is doing right now is it's actually taking a least squares plane, or you can just think of it as an average for the sake of simplicity, an average between these 3 faces on my turn lamp and those 2 faces on my bracket. And so that means that that average is ending up, the average plane to the blue is right here. But because I have 2 faces selected on the red turn lamp, it means the average for that is higher up. And so in order to meet up those two, it has to push the turn lamp further down to line those 2 planes up. This is clearly not what we wanted. This clearly did not go well. So, one idea you could have is, well, we had 2 of the upper planes selected for our turn lamp, so let's just select the upper plane again for our bracket, and then that'll push that one's average plane higher up, and the 2 average planes will line out, and we're all hunky-dory. We're all good to go. So I've done that. I nominal build. It lines up correctly. Huzzah, I figured it out. I figured out how to use the teacher move correctly. Things are looking up. But now when I deviate this time, and I look at it from the side, we're going to see the turn lamp is not doing what we wanted it to do. Remember, I only have a profile tolerance on this face. I do not have a profile tolerance on this face. With the step plane move, it was staying stationary over here. It was keeping its contact with that feature. But with the feature move, because it's doing this averaging thing, it's basically taking the average plane of where these 2 planes end, or I guess 3 planes, end up, and trying to meet them up in the middle with the 2 averages. And it's not actually tipping and rocking it at all. It's just lining these 2 perfectly flat planes up, or perfectly straight planes up. And again, the feature move can get very finicky, and that's why I am just recommending that if it has more than 1 feature in each one, let's not worry about using it. If you want to try experimenting more with it, you can start to understand it better. But for the sake of this, I could talk for an hour and a half about the feature move. For the sake of this presentation, I'm just saying we can save some time by using the feature move in simple situations where we only have 1 feature in each of those fields. All right. Well, whoops, I got to separate my model in order to switch over. All right, so we're back to our phone model here. We've already created our feature move. So let's head back to the PowerPoint. That's number 7. Number 8, so we're about halfway there. Copying points. Points can be copied in 3 different ways in 3DCS, and I'm going to show you all 3 of these ways. The first way is using the copy data dialog, which might be what you're most familiar with. The second way is to use the select function from the points dialog, which a lot of you might not be familiar with. The third way is the copy and paste function just within our tree. So 3 different ways, and let's get at it. So the points I'm going to copy over first are from my lock button right here to my housing, which it locates to. So right now on my lock button, I have all those points. If I scroll down to my lock button here, I could highlight all these. I have all those points that I need for locating it to the housing, but I haven't copied those points over yet. I'm going to turn on my points display and see how that looks. You can see I have a bunch of points over here. I want to copy those points to my housing down here. See, I don't have any points over here. So first tool I'm going to use is just copy data. I'm going to select copy data. I'm going to select my lock button, and then I'm going to select my housing. And then from left to right, I'm going to select all 5 of these points. I'm going to say I want to copy these over using their local coordinate systems, because these parts were made with the same coordinate system in mind. So I can just copy those over very easily by lining up their XYZs to each other when I copy them. I'll say copy. And then again, because these parts were made with that uniform coordinate system, 3DCS is able to line those 5 points up to exactly where they should be around that perimeter of the lock button locators right there. So, but what happens when the parts were not made with the same coordinate system in mind? For example, remember from earlier, these 2 volume buttons, they're the exact same parts. There's no way that the exact same part could be designed with the same coordinate system in mind for 2 separate locations. So that means that my lock button is actually only, or sorry, my volume button is actually only designed for one of these two locations. And I believe, let me check my notes real quick. The volume button was designed for the volume up location. What that means is that if I try copying points over using the local coordinate system from the volume down button to the housing, it's going to copy them to the volume up location because that's where those XYZ coordinates would line up in my overall coordinate system. So let's just do an example of that real quick. And a lot of you probably already know this or learned this in training, but I'm just trying to hammer this point home a little bit. Okay, so I want to select my volume down button right here. Not sure why it's being very finicky here. There we go, got it. All right, and I have these 6 measure points that I want to copy over to my housing. So again, I selected the volume down button. Let's scroll down here. I'll choose copy with local coordinate system selected. And just like I said, we see now that in my tree, I now have those points, these 6 points, but they copied over to the wrong side. They copied over to that volume up side because that's where those XYZ coordinates end up in that, that assembly coordinate system. So that's incorrect. So what can we do to solve this problem? Well, the first thing we can do is delete these points we just created. The second thing we can do is unexplode my model, update to tell 3DCS I unexploded it, and then now I can copy these over using the global coordinate system, which is just where they are globally, and then choose copy, and it's going to copy me an exact copy of that point where it rests on my screen in that moment. So now if I explode my model back out, tell 3DCS is exploded by clicking update model, I now have those 6 points where I wanted them. I can only see 2 in my model right now, but if I were to highlight these 6, we're going to see all 6 of those arrows show up in that vicinity that we wanted them to. Again, a little bit tough with the visualization right now, but you can tell that they're no longer around the perimeter of my volume up button, but they're around the perimeter of my volume down cutout. All right, so that's the first way, and I'm only going to cover that local global thing once. I'm going to cover these next 2 much more quickly. So I'm going to delete the 5 buttons that I copied over from the lock button real quick. And we're going to copy those over again using a different function. So this time we're going to use that select function from the points dialog that I mentioned. So I'm going to select points to open up the points dialog and then select my housing. And then from here, I can use this select button right here, as well as this local and global coordinate system option to determine how to copy some points over or steal some points from other parts is how you could kind of think of this. So I'm going to choose select, and then this select dialog is going to pop up. And then now I can head down to my lock button. I want to copy these 5 points over. So I can select one of them, and then I'm going to get this dialog that asks, do you want to add this point using the local coordinate system, because that's the setting that I currently had selected, to the housing? I can say yes, and I'm just going to click enter for this dialog from now on, just to save us all a little bit of time, and just select all 5 of those. Click close, and then now the moment I hit apply, we should see those 5 points show up right around there again. So there they are. Exact same function, just a different route to get there. All right, I'm going to delete those one more time. Whoops, wrong ones. I want to delete these from up here. So I'm going to delete those one more time. And then this time, I'm going to just copy and paste them directly from the tree. And this is tricky because you don't have a local and global toggle that you're familiar with, that you're definitely selecting. So what 3DCS does is in our preferences dialog, underneath model settings, maybe not underneath model settings, it would be general. Yeah, there it is. Sorry, it's in general for our preferences dialog. It's in the coordinate system right here. You can select whether you're going to default to local or global coordinate system. I'm defaulting to local coordinate system, which means that when I use copy and paste in the tree, it's going to use the local coordinate system to copy the points between parts. So I'm going to select those 5 points again here, right click and just select copy. And then I'll go up here, right click, and select paste. And then boom, again, those points all show up right where they should be. And again, all 5 of those, are in my tree here. All right, so that's copying points. 3 different ways to do the same thing, but it's something you end up doing quite a bit in 3DCS, so I wanted to make sure we covered that.